Hello everyone, good evening. Hello all of you. Do you all hear me? Hey, that's good to see a lot of JEE aspirants today. Well, please do confirm once in the chat box that you are able to hear me clearly. Am I loud and clear? Am I? Yes? Yo. That's good, that's good. Now that you all hear me clearly, let me wish you all a very good evening once more. And before we could begin, let me appreciate all of you for joining a chemistry class on Sunday at 9 p.m. That's great, guys. I see a lot of responses in the chat box that most of you are from JEE and a few of you are from NEET as well. Well, that's fine. You all have answered my question, but then listen to me carefully one more time. How many of you are very serious about your exam? Let it be JEE or NEET. How many of you are extremely serious and want to crack it? Yeah? How many of you? Just say me or me. Yeah? Okay. Akanksha wants to. Then KVPY, that's good. Darshan wants to. That's really awesome, guys. Flood of responses. I love it. Well, you all must be knowing why are we here today, right? We are here to learn some amazing ways to solve chemical bonding questions for either JEE or NEET. As you all know, both the competitive exams have got similar portions, but the questioning level differs. So let's talk about chemical bonding today, but hold on. Before we could jump into the topic, let me introduce myself a little in detail. If you have attended my classes before on organic chemistry or whatever, you must be knowing my name. But if you are doing it for the first time, let me introduce myself. This is Dr. Nasma, chemistry expert at Vedantu. I was a pharmaceutical researcher, but yeah, now I have been teaching from past 6.5 years or 7 years. And I have taken a shift from research to the teaching just because of my love towards chemistry and teaching. Well, I had been teaching at Vedantu from past many years, and I have a privilege to help out many students, hundreds of students, to crack their competitive exams. Well, now that I have introduced myself, let me tell you one more point. I'm extremely passionate about chemistry. Like, I do everything related to chemistry. I research, I write books, I teach, and I clear doubts, etc., etc. But now you tell me, how many of you like chemistry? Let me just look into the chat box. How many of you like chemistry? Honestly speaking. Yeah? By the way, I say hi to each and everyone, those who are responding here. Hi to everyone. That's great, that's great. Princey likes chemistry a little bit. Chemistry is the best, says Darshan. That's great then. The reason I ask you is, even if you like a subject or you don't like a subject, once you're into it, and once you genuinely aspire for clearing any competitive exam, understand that you have to crack it. You have to study it, right? Just before a while, some of you have said that you're extremely serious about JEE or NEET or KVPY. Now, just because you don't like chemistry or something, you can't stop it, right? You have to study. So when you don't have any other option and you got to study, why don't you study with a passion? Why don't you study with a love? If anyone in the class have some negativity about chemistry, just wipe it off and start fresh. Done? Shall we start off with the class? Yeah? Very good. It's tough. It's not actually. Let us see how tough it is. So as you all know, we're going to talk about chemical bonding and we're going to learn some amazing shortcuts today. But my dear students, if you really want to get benefited out of this class of 40 minutes or 45 minutes, just go get a pen and a paper, because we're going to solve many questions today and you will learn them only when you solve. Done? I'm sure you must be having it with you, but if you don't have it, just go get it, right? Well, meanwhile, since we are here to talk about chemical bonding today, how many of you do really think chemical bonding is important? If you think it is important, how important is it? How important do you think it is? I still see people saying chemistry stuff, not exactly. Just tell me the same thing at the end of the class. Yeah, Important, very much important. Okay, can you tell me how important is it? You said important, that's fine, but then how important? Don't know? Well, let me tell you. Some of you are saying that, yeah, it's important because this forms molecules, this forms that, this, etc. Yeah, that's true. But then, to be honest enough, this is very important because it carries a good weightage in your JEE or NEET exams. Yeah. Have you seen the JEE paper of 2018? Is there anyone who have already attempted 2018 JEE? How many questions were there from chemical bonding? How many questions were there? Well, let me give you a hint. There were 3 questions, not exactly hint. Let me tell you, there were 3 questions in the year 2018 JEE mains paper. 3 direct questions from chemical bonding. And 2017 there were 2 questions. Not only these 2 years, if you just analyze past a few years of competitive exams, there will be on average 2 questions directly or indirectly asked around chemical bonding. So you can understand how important is it now. And moreover, chemical bonding is also related to a few other chapters like organic chemistry. It's related to complex compounds or coordination compounds. I hope you know what am I talking of, right? So if you learn chemical bonding, you are also parallelly going to learn partially the other chapters as well. So today let's kill chemical bonding, not the whole, but yeah, a little part of it. Shall we start? Yeah? Well, before we could start, I would like to ask you one more question, and I expect you guys to be extremely honest about it as well. How many of you are really confident in chemical bonding? I'm just looking at the chart. Do not think that I'm looking somewhere else. I'm looking at the chart. So yeah. How many of you are very confident in chemical bonding? Yes, me. Okay. If you are really confident in chemical bonding, how long would you take to answer one question of either JEE or NEET from chemical bonding? How long would you take? 2 minutes, 3 minutes, 1 minute, half a minute, 1 second? What is your speed? What is your speed? A bit? 1 minute, 5 minutes, 2 minutes, 1 minute. I'm so sorry I'm not able to take out all your names, but yeah, I see your responses. That's great. Most of you are saying on average 2 minutes that you will be taking. My dear students, let me just tell you something. Every year, lakhs of people attempt these competitive exams, but the ratio to the people who have attained this exam and got qualified is variable, isn't it? Very less people get qualified out of this exam. What do you think is really important to qualify any competitive? Take KVPY, JEE, NEET, or anything that you want. What do you think is extremely important? What do you think is extremely important? Okay. Well, you think something else is extremely important? I know what that something else is. Accuracy, concepts, test series, concepts, practice, hard work, belief. Such a variety of answers. I love them. But then, my dear students, you be very thorough. You be very thorough in your subject. But then, if you are not able to solve the entire question paper in the given time of 3 hours or 2 hours or whatever, do you think you can top the exam? Do you think it can happen? Not exactly, right? Yeah. So what I feel is, yeah, conceptual knowledge is extremely important. You got to be very strong at your basics, but along with your basics, I strongly believe that you should be very fast, quick in solving questions. How many of you do agree? How many of you do agree that you should be really quick enough to solve the questions? Let it be numericals, chemistry, physics, math, or whatever. Don't you think speed is necessary? The time management is necessary? Yeah, it is necessary, right? What is the use if you know everything and you have taken some 4.5 hours to finish your paper? It's useless, right? So today we're going to focus on how to minimize the time contribution towards the questions of chemical bonding. So if you just look at the paper pattern and the questions, you would have to be solving each question in 2 minutes of time. But then coming to chemistry, and especially coming to a few topics of chemistry, you have a great scope to minimize time. And one topic among those is chemical bonding. I bet you that you can solve any question of chemical bonding maximum in 45 seconds or less than that. Yeah? So let us see how it happens. I'm giving you one question and try to solve this question in 30 seconds of time. So there you go with the question on screen. In which of the following ionization processes the bond order has increased and the magnetic behavior has changed? Let me see who answers it first. I'm waiting for your answers. I see some of you asking about reference books of chemistry, test series and all. I'll definitely talk about it, but please attend of the class. Yeah? Very good. Just tell me the option. 30 seconds is over, but I still have some of you who did not answer. Option 3 and option 2 is what I frequently find here. Okay? Most of you say option 3. Are you sure? Anyways, the correct answer for this question is second option. See, in the given 30 seconds of time, how many of you could solve this question? And those who have given option 3 as an option, 3 as an answer, there you go with the right answer, right? And those who have tried solving and those who are still solving, how did you solve this question? How to solve this kind of question? How to solve? In the question they are talking about bond order, isn't it? They're asking in which of the following ionization processes the bond order has increased and the magnetic behavior have changed. So there are two parts of this question. So first you should identify the bond order change, isn't it? From carbon to carbon plus or whatever. First thing is to calculate bond order and then to identify magnetic property. Correct? Yeah? Then how do you calculate bond order? Bond order is nothing but the average of the difference between bonding and anti-bonding electrons present in any molecular orbital. Correct? So you have to first write electronic configuration of C2 and then of C2 plus 2. Identify how many bonding electrons and how many anti-bonding electrons do you have, and then take the difference, divide it by 2, identify bond order, and then compare if it is increasing or decreasing. That's not over, and then you have to go compare magnetic property as well. Isn't it time consuming? Yeah? Is it a little time consuming? Yes, it's a long process and it works if you're talking about board exams or something, but do you need a shortcut to solve this kind of question in 30 seconds of time? How many of you would need a shortcut here? How many of you would love to have a shortcut to find bond order, to identify magnetic property of any element, right? So shall we look at the shortcut? Well, so before we could go to the shortcut, let me just give you a disclaimer here. Any shortcut that we use, it's useful only when you keep it in mind. Yeah? So try to memorize the shortcut. There we go. Anytime that you got to calculate the bond order of any molecule, the first thing that you have to see is count the total number of electrons present. For example, we were talking of C2 in the first option. So total number of electrons in C2. Total number of electrons in C2. Come on, carbon. One carbon has 6 electrons and 2 carbons have how many electrons? There are 12 electrons, right? Yeah? Very good. So then, after finding total number of electrons, then what? Observe this range. If the total number of electrons are falling into 1 or 2, 1 to 2, it's a range. Then the formula to calculate bond order is n by 2. What if the total number of electrons is falling between 3 to 6? Then the formula to calculate bond order is 4 minus n by 2. Always remember, out of this formula, you might get a positive or a negative value. The sign doesn't make any difference here. You just need the magnitude, forget about the sign. Done? Well, what if your total number of electrons are falling between 7 to 14, the way it is happening with carbon, 12 electrons. So carbon belongs to this category. The formula here to calculate bond order is 8 minus n by 2. And if the total number of electrons is 15 to 20, there you go with the formula. By the way, what do you think n is here? Can you tell me what could be n? N is, come on, n is, very good, n is nothing but number of electrons, and I see some of your comments that you're not able to see the last formula. I'm writing it here, 20 minus n by 2. Do you see it now? Right? Well, so N is number of electrons and you just got to apply the respective formula based on total number of electrons. Now what shall we do? Let's go back to the first question, look at 4 options and then let's calculate the magnetic property. Done. There we go. I already have written it because I did not want to spend much time on writing here. Rather, I wanted to spend time on understanding your chat messages. Done. So there we go. The first option, C2 to C2 plus. Carbon, 12 electrons, C2, 12 electrons and C2 plus. Because there is one positive charge, total number of electrons is how much? 11, right? Because the total electron count is falling between 7 to 14 category, there we go with the formula. Yeah. Since you guys are not able to see the formula, I'm just keeping my webcam off for a while. Yeah, I think that should do. There you go with the formula, 8 minus n by 2 and n is number of electrons. So there we go. We are substituting n value 12 in the formula and simplifying to calculate bond order. Bond order is 2, right? And this is minus 8 minus 11. 11 is n value. What is this? 11 and 12 here. N is equal to 12 in case of C2. In case of C2 plus, N is equal to 11, which is nothing but total number of electrons present. Done. So now there you go with the bond order for both the molecules. Correct? Yes? Well, that's great. Now, can you try doing it for the remaining 3 options and check if the bond order is increasing or decreasing? Quickly. I'll take you back to the previous slide of the question. Number 1, it should be here. Yes. Can you calculate the number of electrons and then finally calculate bond order and tell me in which option is the bond order increasing? I'm waiting for your answers. Yeah? Very good. Sushma is done first. But Sushma, are you sure it's only option 2? And then is Lalit. For those who are saying option 2, are you really sure it's option 2 alone? Or is there any other option which falls into this category? That's great. Flood of responses as usual. Vikas, Science K Legend, option 3. Darshan, option 4. Ankit, only second option, please do verify. Well, that's good. Now let me just reveal the answer. Okay, ready for it? I have seen a mixture of responses between option 1, option 2, option 2, 3 and 4. And finally, there you go. There you go with the bond orders being calculated already. Yeah, as I told you already, if you see me on and off, my webcam is on and off, do not worry. It totally depends upon how am I using the screen. Yeah, well, the first option, bond order is changing from 2 to 1.5. It's not increase, rather decrease. 2.5 to 3. Is it increasing? Yes. So second one is in. 2 to 2.5. Third option is also showing increase in bond order. Correct? And fourth option, 3 to 2.5. But most of you said 4 as well. Correct? Must be in hurry. You got to be accurate also. Right? So option 2 and option 3 have possibility to be the right answer. But then if you go back to the question and observe the second part of the question, do you see? They're also asking about one such option in which magnetic behavior is changing. What is magnetic behavior, by the way? Anyone in the class, please? What is magnetic behavior? Magnetic behavior. Okay. That's great. How many types of magnetic behaviors are seen usually in the molecules? Paramagnetic, diamagnetic are most common, right? Ferro, ferri, etc. do exist, but they are not so usual, correct? And now out of second option and third option, we also should verify wherever magnetic behavior is changing. So how do you verify that, guys? How do you get to know if some molecule is magnetically active or inactive or whatever? How do you get to know? Okay, but how? I see your answers. Rahul says diamagnetic, and yeah, that's good. Sushin says due to number of unpaired electrons. Okay, with the help of bond order. Yash says by molecular orbital theory. That's good. That's good. And now you know the number of electrons. Can you find out the magnetic behavior? Can you verify if it has any unpaired electrons? Write the configuration, then write the molecular orbital diagram. You will have enough time in exam, right? In fact, not. We have to save time, correct? So it's not possible you go on writing electronic configuration here. So we would definitely be needing a shortcut for magnetic property as well, isn't it? How many of you do need it? Would you want to know a shortcut for magnetic property also? Yeah? Yeah? Okay. Let me see how many of you really need it. Advait, Lalit, yes. Oh my god, it's too rapid. I could not take out many names. I'm sorry for that. Well, if you need it, let me just tell you. Usually magnetic property which is exhibited is paramagnetic or diamagnetic, correct? What is paramagnetic? Paramagnetic is being deflected in presence of magnetic field, and diamagnetic is the other way around, not being deflected, just being neutral, isn't it? And according to chemistry, magnetic behavior is all due to unpaired electrons, correct? It's all due to unpaired electrons. So now, if you find a species which has unpaired electrons, what does it mean? It should be paramagnetic by nature, correct? So first thing is, we should find the species if it has paired electrons or unpaired electrons. And I'll ask you one simple question. If all the electrons in the molecules are perfectly paired, the total number of electrons, could it be odd? Would you be able to find odd number of electrons if all the electrons in the molecule are paired? Pairing is nothing but being double, isn't it? If there are 11 electrons in a molecule, and if I say these all 11 electrons are completely paired, can it happen? Well, it can't happen, right? There could be 5 pairs and 1 single electron, right? So, can we generalize it as, if you have odd number of electrons, you have one or more than one unpaired electrons possibly existing, and that might cause paramagnetic behavior. We can generalize, right? There are exceptions, I'm coming to that, but before. And if you have an even number of electrons, possibility is that it could be diamagnetic, because usually even number of electrons will give you perfect pairing. But then, guys, do you think there could be exceptions for this? Is it necessary that if I have 10 electrons, all the 10 should exist in 5 pairs? Is it necessary? It's not necessary, right? Yeah? Why is it not necessary? Because if I have 10 electrons, there could be 4 pairs existing, and remaining 2 electrons will exist as single electrons, because 2px and 2py, they will have same energy levels, right? 2py and 2pz have same energy levels. Remember molecular orbital diagrams? Exceptionally even number of electrons could be sometimes behaving paramagnetic. Why? Because there are 2 or more than 2 molecular orbitals which could possess similar energy. Remember molecular orbital diagrams? Yeah? So, this generalization has an exception, and the exception is all odd number of electrons are paramagnetic, undoubtedly, but then even there are exceptional cases, and those exceptional cases are if you have totally 10 number of electrons in the molecule or 16 number of electrons in the molecule. What is the expected magnetic behavior here? Because the numbers are even, what could be expected? What could be expected here? Because it's even, come on. Yeah? We expect it to be. Thank you so much for reminding me whenever you're not able to see the screen completely. Thank you so much. You will be able to see it now. Okay? That's great. So, it is expected to be, because even number of electrons, it has to be diamagnetic. But then, these are exceptional electronic counts and they behave paramagnetic. Even if they are having even number of electrons, they will be behaving paramagnetic, right? So, remember, find any odd number of electrons, it's paramagnetic. Find any even, it is diamagnetic, except total 10 electrons and total 16 electrons. Now let us try applying the same thing to this question. Yeah, coming back. Here is the total number of electrons, right? Let me just take only total number of electrons. Yeah, do you see total count of electrons here? You do, right? Well, C2 has how many electrons? 12. It's even count. So what do we expect this to be? Para or dia? Para or dia? It got to be? Very good. It has to be diamagnetic. Why? Because it is consisting of what? Because it is consisting of even number of electrons. Now, tell me the magnetic property of C2 plus. It has to be paramagnetic. NO is nothing but nitrogen monoxide. It looks like small letter, but it's capital. 15, it is expected to be para. 14 is dia. Now tell me the magnetic property of O2. Let me see who answers correct and first. Diamagnetic. Are you all sure? Exceptionally. Very good. There are a few students who are saying it's paramagnetic. Right guys, it is paramagnetic. Why? Because it has count 16. Count 10 and 16 is exceptional. Correct? So it got to be paramagnetic. Now, what is the question? We have to identify a magnetic behavior change as well, right? So in the first option, we are having dia and para, but what to do? We don't have the expected bond order change, right? It has to increase. It is decreasing. So it cannot be option 1. So option 2, yes, bond order is increasing, and moreover, look at the magnetic behavior. Magnetic behavior is changing from where to where? From para to dia. Now observe third option. It is para and being para. Bond order is increasing, but it can't be the right answer. Correct? So correct answer should be option B. Now, since we are discussing, we have taken so much of time, but do you think with the help of these shortcuts, you will be able to reduce the time that you are consuming to solve this kind of questions based on bond order and magnetic behavior? Do you think you can, you can save some time here? Yeah? Okay, how many of you think? That's great. That's great, many of you. Right then, so let us check if you are really able to save time or not. Let us check with the help of one question. Ready for a question? Well, I'm not going to explain the question to you, but you would have to tell me the answer. There you go. Which one of the following pairs of species have the same bond order? You have 30 seconds of time. Go on. Well, waiting for your answers. There are 4 options. It's a pretty similar question, but then it's not asking you about magnetic behavior. I'm sorry. Okay. Quick responses I'm getting. That's good. That's good. Okay, almost everyone. Last 5 seconds. Very good. Right then. So most of you have answered. Then shall we see which is the right answer? Yeah? Let us. It is option 3. And when I have analyzed your chat messages, I guess approximately 60 to 70% of you are right. But a few of you went wrong saying option 1. I guess it's a silly mistake. Make sure you're accurate enough. Let me just brief you how did we solve this. We just got to identify the species which are having same bond order. So we have to calculate the bond order here. Correct? So how do you calculate bond order? We have to calculate with the help of electronic configuration, count bonding electron, anti-bonding electron, take the difference. Am I right? We have to do the same way, isn't it? Should we? No, it's actually not. We have learned some shortcut here, right? What is the shortcut? Someone who has missed it, there you go, my dear. It's a formula. First thing, count the number of total electrons, and if your total electron count is falling between 1 or 2, your formula is n by 2. 3 to 6, 4 minus n by 2. 7 to 14, 8 minus n by 2. 15 to 20, 20 minus n by 2. One thing that you got to remember here is the value, the outcome of this formula, the resultant of the formula, let it be positive or negative, doesn't make any difference to you. You just focus on the number that you get. Done? Is everyone clear? Is everyone clear? Yeah? That's great. Some of you who are saying that you're not able to see the last formula, there you go. This is the final formula. 20 minus n by 2. Done? Learned it? Shall we go with one more question? One more question? Yeah, not this question, do not worry. This doesn't fall into what we discussed today. There we go. According to molecular orbital theory, which of the following will not be a viable molecule, or which of the following molecules does not exist? Let me see who answers first. Vikas has said something. Then is Utkarsh, Manas, Saisri. Well, okay. Waiting for rest of you. Hurry up. You know, right? You just have 30 seconds to solve any chemical bonding question. Only then you will be able to save some time here and spend more time on complicated stuff like electrochemistry, chemical kinetics, thermodynamics, and the legend of chemistry. Legend of chemistry is organic, right? The conversions and all that. Very good. Very good. Well, there we go with the right answer. It's option 3. I see most of you saying option 4. Calculate the bond order. What does it mean if molecule doesn't exist? Like, how do you get to know if molecule exists or not? How do you get to know? You get to know when you calculate the bond order, isn't it? So first thing, you got to calculate the bond order, and after calculating, when is the molecule does not exist, or when a molecule is viable, when the bond angle is bond order is 0. What does it mean if I say bond order is 0? Like, I mean, what is the reason behind a molecule not existing when bond order is 0? Anyone in the class? RSR, right answer. Good. The bond order is nothing but how many bonds on average are present between two atoms. If bond order is 0, it means 0 bonds are present between two atoms. When there are 0 bonds or when there are no bonds, can we expect a molecule to exist? Not exactly, correct? So, wherever bond order is 0, it means the molecule does not exist because there are no bonds being formed between the atoms of that molecule. Done? Right. So now let me ask you one question. Just be honest enough. Did you understand the short trick to calculate bond order? Yeah? And let me tell you something. There are many more tricks related to chemical bonding. It's only one. And to calculate bond order also there are many formulae. But I found this to be best and time saving. Right? And how about magnetic property? Tell me what could be the magnetic behavior of a molecule which has 10 electrons in total. Which has 10 electrons in total. 10 electrons. 10 electrons. Paramagnetic. 10 is even, right? It should be diamagnetic, isn't it? Should it be diamagnetic or something? It is exceptional. Very good, guys. Very good. So, what did we do so far today? We have understood how to solve bond order questions in no time and magnetic property questions also in no time, right? So this way, practice chemical bonding in such a way that you should be able to crack questions. It's not will. You should be able to crack chemical bonding in 30 seconds. That is the average time span that you can give to a chemical bonding question. That's when you will be able to manage your time to solve all the chemistry questions. You know, right? There are many complicated chapters in chemistry, like electrochemistry, numericals. How long does it take? Kinetics, numericals, organic chemistry, conversions. So spend less time to this, and that is possible when you learn many shortcuts. These are just 2, but there are 9 more shortcuts related to chemical bonding, which will shortly help you to crack your questions based on this chapter in 30 seconds of time. So, would you want to learn those tricks as well? How many of you would learn? I mean, how many of you would be really interested to learn those tricks? Yeah? Yes? Okay? Very good. Well, so if you're looking for learning the tricks of chemical bonding, all the tricks of chemical bonding, and understand how to solve any chemical bonding question in less time, there you go with the news. Vedantu is launching a master chemical bonding kind of course where you will be taught all the tricks related to chemical bonding, and this is just a 2-hour course, not more than that. Do you think for learning shortcuts you need more than 2 hours? If you want to learn the entire concept, entire chemical bonding, that's a different thing. But to learn short tricks of chemical bonding, I guess 2 hours is more than sufficient, right? So there is a course being launched at Vedantu, Master Chemical Bonding, in which you will be taught all the tricks related to the chapter, along with the assignments or the multiple choice questions as a practice. Well, so anyone interested to know more about it, you can follow me with the link. So there is a link. Well, the link is, you want the link? Yeah, the link is being pasted in the chat. Do you see it? vdnt.in/2wty2, right? Just click on the link, you will be redirected to this page where you have all the information about the course. Yeah, it's going to be just a 2 hours course which is going to happen soon. When is that soon? It's on Wednesday from 7 to 9 p.m. 19th of this month. And what do you think is the price of this course? What do you think is the price of this course? Any guesses? Any guess? Yeah, the price of the course is going to be 51 rupees. Yes, it is just 51 rupees, and this is an initiative from Vedantu to get JEE NEET preparation accessible to every student irrespective of any constraint, right? So there you go with the course page. Once you click on enroll button, you will get the bundle page this way. And one more thing that I would like to add here, the number of seats is pretty limited. Will not be taking as many students as we come. There is a constraint as well. So if you're interested and if you're looking to crack chemical bonding really well in no time, there you go with the link. Done, guys? Yeah? Right. And one more thing, if you are looking for this kind of shortcuts in other chapters of chemistry, like let it be however tough, I mean it. If you are looking to learn shortcuts of any chapter of chemistry, JEE, NEET, KVPY, make sure you comment it in the comment section so that I get to know and I can launch more webinars and more courses on this. Yeah? Right? Very good. That's great, guys. That's great. Make sure you let me know the name of the chapter. So whichever goes on majority, I'll be taking webinar on that. Done? Very well. Atomic structure, aldehydes and ketones, listed in the comment section. Let me understand from there. Done? So well, guys, that's all about our today's class. I repeat, if you're really looking out to crack your JEE or any competitive exam, you would need to answer questions in less time. You should be able to save time, and one wonderful way to save time is using the shortcuts. And one wonderful platform to learn those shortcuts is right here in front of you. I would love to see all of you in my sessions. So let me see how many of you will be there. Yeah? Well, and some of you were asking about the reference books for chemistry. Which books are you referring? Organic, Solomon. If you want to learn right from the basics, the concepts, practice, everything A to Z is in Solomon. Done? NCERT is like the first step. You don't study NCERT, then literally I can say that you don't study any other book. First is NCERT. Done? After NCERT is the reference book. Without NCERT, don't go anywhere. Very well. Pradeep is a good book, but then honestly speaking, Pradeep has got some errors. If you can identify them, that's well and good, but if not, it's a risky stuff. Yeah? NCERT is holy book. I appreciate that statement. Yes, it is. OP Taunton is also pretty good, but then I refer OP Taunton for inorganic chemistry, not for organic and physical. That's because inorganic chemistry is fine with OP Taunton, but organic and physical, when I was referring, I found some errors in the questions. So if you're okay with the errors, then go ahead with it. Done? Well, guys, so this is all about our today's session. And as I told you, do remember to let me know the chapter names in which you need the shortcuts. You need more and more this 51 rupees courses being launched. Do let me know, and I'll just go over the number of comments in the video and the majority of the chapter. Done? So I'll see you all in my session on Wednesday, 19th of this month at 7 p.m. Yeah? Do I see you all? And guys, if you want to know what shortcuts do we cover there, we'll be talking about the numericals or questions, how to solve questions on bond angle, bond length, hybridization, polarity, dipole moment, Fajon's rules, and a little more about magnetic property, bond order. And if you have practiced it more than enough, you by now should have been known. The questions will be bridge questions. Based on bond order, you should be able to find bond length. Based on bond order, magnetic property, or based on bond length, bond angle, vice versa, right? So we are going to focus on such cross bridge questions as well in our 51 rupees course, which is going to happen on 19th of this month at 7 p.m. Done? Right? Very good. So any questions or the chapter names, I would look forward in the comment section of this video. I'll see you all in my session. So let me sign off for today. Any doubts or any questions, please do put it in the chat box. I will be addressing them. Right? So I'll see you all. Bye-bye everyone.